This video is about a 3D printed dissolvable mold, and what I'd like to show to you is the process I've been using with reasonably good results for making a 3D printed mold, dissolving it away, and leaving you with a cast. And it's going to be the process that I'm showing, not necessarily the end result. The advantages of a dissolvable printed mold is that it's good for asymmetrical designs, where a split mold would be complicated to make. It's also good for prototyping when you're making frequent design changes and you don't necessarily need a mold that you can use on multiple different times. I've been using this for a project that I actually can't show today due to intellectual property reasons. So instead I've made a simple representative project, and this is just the toy octopus that I'm filling with silicone to make a toy squishy for kids. I've used Fusion 360 for the Cad Drawing. This is just representative of the wireframe. And the way to make this shell, there's different ways to do it. You can make a solid model and shell it out. The other way to do it though is to make the model, make a copy and upsize it by 10% or some other dimension to give you about a 1mm shell. And that's actually the way I have been typically doing it. So the two models, and then bring them together, delete the inner model, and it leaves you with a shell of whatever size you set, so usually about a 1mm. And this wireframe shows that 1mm shell. So this will be 3D printed as a shell and filled with silicone as the mold for the cast. This is the final CAD drawing. You can see also at the top there's a orifice for basically it's a lower lock, and that's how I'm planning on injecting the silicone. The filament I've been using for this is the Spoolworks Labs. It's the scaffold, the soluble, dissolvable type scaffold. I think it's a PLA based filament. And it actually works pretty well. In my printer, I've been heating the extruder to 204 and the bed to 40 degrees. With this, it's been pretty reliable. It's a fairly easy filament to print. My printer is a Soluble 4, which is pretty long in the tooth, and it was okay for its time, but it's not the best printer and not the most reliable. But it does an okay job with ABS, and with this filament it's okay. But just a picture of it printing out. You can see the developing shell of the octopus legs. So for this toy squishy, I'm going to cast a soft silicone. This one I'm using Smooth On. It's an EcoFlex 00-20. Which is a relatively soft silicone, and it's reason I'm using this is basically because I have this from a previous project and I think it'll work pretty well. This one is mixed 50-50, and I think it has a pot life of somewhere around 20 minutes. It cures relatively quick. And for this I'm using a white pigment. The pigment goes a long way. I probably put way more in than I need, but just mixing that in with part of the silicone and then mixing everything together. So with the silicone and the pigment all mixed together, in this case I'm using a syringe to inject the silicone into the mold. Like I said earlier, I have a Lower lock type orifice at the top, and that's going to accept the syringe. So just injecting it in basically until it comes out. On each leg I have a small hole where the silicone will come out when the mold is completely filled. And it's important to purge a bit of silicone through. There is the occasional air bubble. Of course, the more you purge through, the less chance of an air bubble. So I cast two, one with the Lower type fitting and one with just an open head, and basically just injected silicone into both, gave them time to cure. To dissolve the filament, I'm going to use a cheap ultrasonic cleaner. It works pretty well, it heats up the water well, and it speeds up the process. Alternatively, you could just soak them in water overnight or for a few hours, and that would work well as well. With the machine turned on, you can see pretty much right away the filament starts dissolving. I left them in for usually 15 to 20 minutes, and that works pretty well. A few minutes later, the mold is starting to soften up and more of the filament is dissolving. So after about 20 minutes, they're pretty soft. A fair amount of it's dissolved already. And to speed up the process, I'll just give it a rinse and a bit of abrasion, and it comes off pretty quickly. And here's one of them. You can see most of the filament is coming off the silicone. The silicone is in pretty good shape underneath. And again on the other one, most of it comes off easily. I did put these back in the ultrasonic cleaner after this for another 10 minutes, and after that, pretty much all the filament from the mold was gone. So these are the silicone casts. Like I said, they're just silly squishies for my kids to play with, but I think it shows the process of making the mold and then making the cast. They turned out pretty well. There's a few little air bubbles on one of them. The one that I used the Lower lock to purge through worked out better with no real air bubbles. The quality of the cast depends on the quality of the 3D print. You can't see some of the lines, but I think that's more a testament to the quality of my 3D printer or lack thereof. But overall, this process does work well. Like I said, I would recommend it if you're prototyping and you want to print a mold of something that's not really amenable to a split mold, but this does work pretty well. Obviously, it's a pretty inefficient way to make silicone squishies, but it is good for prototyping. Thanks for watching.